I'm getting there, folks. Okay, so again, what the test will look like, this is obviously not for us, this is for something else. Okay, now when I had these printed out and put, I thought we were meeting face to face, but we're not. So when I show it to you all, you don't really need this, and you don't really need name, row, or seat. And the directions are kind of obvious. You don't write anything on this, So I might go like this. So there's about 10 questions. So I'll give you maybe 15 seconds. Either do a screenshot or get out your cell phone and take a picture. And then after 15 seconds, I'll scroll down to the remainder, something like that. So I'll give you 15 seconds for that and blah, blah, blah. And then after that, I'll just put it away. And that's what the test will look like. Okay. And when I email you or send on Canvas the test, then you've got the whole thing already anyway, right? So there we go. All right, so I think I'm ready. Let's see, 1.8, number 41. Okay. And yet the only questions I'll take are stuff from the homework, please. So if you had a question about something outside the homework for the benefit of everybody, I'm not going to do it to save time. If you really want to know, email me later or come see me during office hours. And the only thing you need to study for are the test questions. And I will either ask the very same question or a slight variation of it. Okay, so that's how you study for it. Okay, 1.841 was asked for. Let me see what that one's about. Okay, so it's that one. Okay, so you have this piece right here. Express the area as a function of x. Okay, so 1.841. In the interest of time, I'll be very crude on how I do stuff. Okay, so they had this. Y equals 4 minus x squared. This is x. This is y, but y is equal to 4 minus x squared. Okay, so they want an expression for the area. So by symmetry, if this is x, this is also x. So this distance is 2x. So the area as a function of x is base times height. The base is x, and another x is 2x. 2x times the height, which is y, but they told us y is 4 minus x squared. Okay, so that's basically it, or you can multiply it out. What, 8x minus 2x cubed would also be an acceptable final answer. Okay. All right, let's see. Maxwell, you're good, so don't worry about it. Okay, so just do what you got to do. 1.645. I'm sorry, I might be going fast, but yes, I am aiming for what, quantity rather than quality, because I want to get as much in as possible. You can go back and review the video later and slow down, obviously. Let's see, we have 1.645. 1.645. 1.645. F of x. Whoops. Not what I wanted to do. Okay, and again, I think I'm going to go straight to C. Again, if I do C, I'm doing A and B, right? A is included in C, B is included in C. So I'll go straight to C, and then I'll do D. Okay, so f of x plus h minus f of x all over h. So there's the h. So fraction minus fraction. Okay, so f of x is just the original, x minus 3. So this stuff right here is my f of x. F of x plus h means put x plus h right there. Put x plus h right there. So I have this. Okay, and now I want to clean that up. You might recall the trick, if you divide by h, which is like h over 1, you can say multiply by 1 over h, like that. It just looks better. So dividing by h is the same as multiplying by 1 over h. Okay, and now that minus that, x plus h over x plus h minus 3. Leave a space. If you're copying what I have, leave a space. And again, I realize that you might be saying, hey, I didn't know how to do this problem. So, hey, he's doing it. He's helping with more of the homework. Yeah, you're right. Okay, we're almost to the point where I've done maybe close to all of them. So there should not be any issue with the 70% rule. I did a whole bunch, and now it looks like I'm doing a whole bunch more, right? Okay, so common denominator, this side needs that, this side needs that, right? I mean, let's think of simple fractions. Suppose you had a 5 here and a 7 here. Well, the 7 would multiply by 5, and the 5 would multiply by the 7, right? So that means this side needs that, and this side needs that. So all you do is multiply this side by x minus 3 over x minus 3. And this side needs x plus h minus 3, x plus h minus 3, x plus h minus 3. So it looks like a big mess, but we'll try our best to get through it. 1 over h. Okay, the denominator is now common, x plus h minus 3. So x plus h minus 3, x minus 3. And by the way, do not multiply out the bottom usually. Okay, it's usually not necessary to multiply out the bottom. I am going to work out the top. So let's see. FOIL, right? X squared minus 3x plus hx minus 3h minus x. And I think it's easier if you think of it that way, so you don't avoid this. I'll put the minus here and change that to a plus. That'll just help me to remember I'm really distributing negative x. So negative x times all this stuff. So negative x squared minus xh minus a minus 3, so plus 3. Okay, so I think I did that right. And let's see if anything cancels out. So anything cancels out here. X squared minus 3 h minus, see, I think I made a mistake. Minus x squared minus xh minus 3x. Right, that should be an x there, sorry. I'll just put the x there and then it looks like I didn't mess up. So let's see, negative x squared minus xh plus 3x. Yeah, okay. So that's gone. That's gone. That's gone. Right. So everything is gone on top except for a negative 3h. Negative 3h over 1 over h times x plus h minus 3, x minus 3. And even the h's cancel out. Cancel, cancel. So final answer is negative 3 over x plus h minus 3 times x minus 3. So that's the answer to C, which actually incorporates A and B. Then D, when it says h approaches 0, now you just plug in 0 for h. So I'll put a 0 right there. We get negative 3 over x minus 3, x plus nothing minus 3 times x minus 3. Well, that's x minus 3 times x minus 3, or negative 3 over x minus 3 quantity squared. Okay, so that's it for that one. Okay, and let's see, what is next? Okay, 45, 1.6, 1.353 maybe? 1.353. Yeah, that was a pretty interesting one. 1.353. So from exercise 51, you have the points negative 1, 4, negative 3, negative 4, and 2, negative 1. So 53 refers you to 51. Find a fourth point so that the vertices of a rectangle when added to the points form a rectangle when added to the points. Okay, so this one unfortunately got to go quickly here. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 3, 4. Okay, so given points are -1, 4, -3, -4, and 2, -1. Okay, so there's a point out here somewhere, they're saying. Maybe it's here somewhere. So that you end up with a rectangle. So find such a point. So first I have to find some distances. So this was the point -1, 4, -3, -4, and 2, -1. Okay, I'm going to be going somewhat fast here, but you need these distances. This was radical 34, I believe. Okay, so I should just throw it in a distance formula. Square root of 4 minus a -1 squared plus -1 plus 2 squared. I think it's radical 34. And this one was also radical 34, I believe. Am I right? Yeah, radical 34. So this has to be radical 34. And this also has to be radical 34 in order for it to work. Okay, so I use the distance formula for a given x, y. So x minus a -1 squared plus y minus 4 squared square root equals radical 34. And also the distance from here to here is radical 34, namely radical x plus 3 squared plus y plus 4 squared is equal to radical 34. Okay, so I'm using the distance formula from this given point to here and also to here. Okay, let's see. I can square both sides, and these two now have to be equal to each other because they're both equal to radical 34. Okay, so in other words, x plus 1 squared plus y minus 4 squared is equal to x plus 3 squared plus y plus 4 squared. Okay, the thing under the square root has to equal the thing under the square root here. Okay, so this is x squared plus 2x plus 1 plus y squared minus 8y plus 16 equals x squared plus 6x plus 9 plus y squared plus 8y plus 16. Let's see. And I can subtract x squared on both sides. I can subtract y squared on both sides. Looks like 16 cancels out. Very nice. So now what do I have? On this side, I have 2x minus 8y plus 1. And on this side, I have 6x plus 8y plus 9. Subtract x squared, gone. Subtract y squared, 16 is gone. So 2x plus minus 8y plus 1, 6x plus 8y plus 9. Okay, I think I'm good. Let's see. How about I will throw these guys over here. Okay, 2x equals. So I'm adding 8y, and I'm subtracting 1. Whoops. Didn't want it. Plus 6x, sorry. So the only thing here is 2x. Add 8y, 8y plus 8y, 16y. Subtract 1, 9 minus 1 is, let's see, what did I do? 9 minus 1 is 8. 9 minus 1 is 8. My bad. And leave that alone. Okay. Divide by 2, divide by 2. No. You know what? I messed this up completely. Sorry. It's worse. Sorry. 6x got to come over here. Is that right? I want all the x's on this side. Okay, that's bad. So 2x minus 6x is negative 4x. And that is 16y plus 8. Okay, now I think I'm good. Divide by negative 4, divide by negative 4. X is equal to negative 4y minus 2. Okay, I plugged that back into, let's say, here. Okay, and it's going to look like this. So negative 4y minus 2, that's x, plus 1 squared plus y plus 4 squared equals 34. Okay, so what am I doing? I'm taking this equation, taking off the square root, and putting in place of x, negative 4y minus 2, like that. Okay, so that's going to be negative 4y minus 1 squared plus y plus 4 squared equals 34. See, 16y squared plus 8y plus 1 plus y squared plus 8y plus 16 equals 34. 17y squared plus 16y plus 16 equals 34. Let's see. Something's not right here.
I think it's plus 17.
Plus 17 here? Plus 17.
No, plus 1.
Plus 1, right, thank you. Okay, looks like I've messed up again, unfortunately, folks.
Also, I think you could have canceled out the 8y's in the big equation before.
Yeah,
Like,
I think the 8y's are supposed to cancel, but I'm missing that right now. Anyway, they're supposed to cancel and I get y equals plus or minus 1, but I'm missing that right now. And so it looks like in the interest of time, I'll have to abandon the problem so I have time for others. Okay, so what should I say? I messed up. Okay, so there. Okay, I could keep trying to fix that. I don't think I'm going to, so I apologize about that. So I'll have to abandon that problem. Sorry about that. So let's see. Okay, 1.433. Y equals radical 9 minus x squared. Okay, intercepts. Plug in x is 0. You get square root of 9, which is 3. Plug in y is 0. Then x can be plus or minus 3. Because 9 minus x squared equals 0 means I can plug in either 3 or negative 3. Those are the intercepts. Okay, symmetry. Replace x by negative x. Y equals square root of 9 minus negative x squared. That is the same as the original. Okay, so it's the same as the original. So I have y-axis symmetry. Replace y by negative y. All that happens is you put a negative y there. So that's not the same as the original. So no x-axis symmetry. And if you do both, and by the way, on the test, I'll let you just write both, B-O-T-H. That's fine. You're doing both. So negative y equals square root of 9 minus negative x squared. And by the way, again, the way to do these kind of problems is to replace x by negative x, y with negative y, etc. You're not supposed to draw a graph and just say, oh yeah, from the graph, there's x-axis symmetry or y-axis symmetry or origin symmetry. You have to do it by this method. Okay, so that gives me negative y equals radical 9 minus x squared. That's not the same as the original. So no origin symmetry. Okay. And let's see. Okay, 49 was asked for. I'm going to come back to that because I'm not sure if I have time looking at all the questions that we have here. Okay, so somebody asked for 1.449. I'm going to put that on hold in the interest of getting more problems in. 1.351. Okay, I think I can do that. 1.351. Find the distance between the points, whatever, okay, negative 1, 4, negative 3, negative 4, 2, negative 1. Right, that kind of goes along with the 53. and show that these are the vertices of a right triangle. Show that you have a right triangle. Okay, so how about I'll call them P, Q, and R, just for labeling purposes. So PQ, PR, QR. Throw it into the distance formula. Looks like this. X2 minus X1 squared plus Y2 minus Y1 squared. Yeah, I think the book actually goes 1 here and 2 here, but it's the same thing. You go 1 and 2. I mean, the points don't care which is first and which is second. Okay, so basically you subtract and square. So -1 minus a -3 squared, and 4 minus a -4 squared. So that's going to be 2 squared plus 8 squared, which is radical 4 plus 64. That's radical 68, which is 4 times 17. So 2 radical 17. 2 radical 17. P to R, distance from here to here. So -1 minus 2 squared. 4 minus a -1 squared. So that's -3 squared. 4 minus a -1 is 5. 5 squared. So that's 9 plus 25. Radical 34. And then the distance from Q to R. So how far is it from Q to R? It's here to here. So -3 minus 2 squared. And then -4 minus a -1, a lot of negatives. -4 minus a -1 squared. So that's -5 squared. And that's -3 squared. So that's 25 plus 9 equals radical 34. Okay, so those are the distances. Show that you have a right triangle. Okay, so that means a squared plus b squared equals c squared. It looks like the square of PR plus the square of QR equals the square of PQ. So PR squared plus QR squared. Radical 34 squared plus another radical 34 squared. That's 34 plus 34, which is 68. And that's equal to PQ squared. It was radical 68. Okay, so that proves we have a right triangle. So we have a right triangle. Okay. All right. Let's see. See what I'm willing to do here. 1.629. Okay, 1.629, there's an A, B, or C. Do you have a preference, Julia? Otherwise, I'll just...
No, either is fine.
Okay, 1.629. Oh, what do I want to show you? How about C? That looks the hardest. X equals 2x squared over x squared minus 2. And find a domain. Okay, so it's got a square root. So the thing behind its square root has to be greater than or equal to 0. 2x squared over x squared minus 2 greater than or equal to 0. Okay, so my boundary numbers are 0. What makes the top 0? 0. What makes the bottom 0 are plus or minus radical 2. And I did it before, it's like 1.4, something like that. Okay, so number line 0, 1, 2, -1, -2, 0. Radical 2 is like 1.4 and -1.4. Okay, plug them in. If I plug in 0, that gives me 0 on the top. 0 divided by that is 0. True statement. Plus or minus radical 2, that'll give me a 0 on the bottom. That's a no-no. So this is closed, but both of these are open. 0 will give me a true statement. 0 is greater than or equal to 0. But plus or minus radical 2, plug it in, you get a 0 in the bottom. We can't do that. Okay, region 1, 2, 3, 4. 1, 2, 3, 4. My expression has a fraction, so fraction bar, fraction bar, fraction bar, fraction bar. Let's make things easier on ourselves. What do you notice about the top? 2x squared. It's always going to be positive. As long as I don't plug in 0. I'm not plugging in 0 now. I already did 0. Okay, so plus, right? Oh, I didn't even pick my number here. Okay, so -2, -1, 1, and 2. Okay, let's see. -2 squared is 4. 4 minus 2 is positive. Positive divided by positive is positive. Positive greater than or equal to 0, that's true. Region 1. Plug in -1. Squared is 1. 1 minus 2 is a negative. Positive divided by negative is negative. Negative greater than or equal to 0, that's false. Do not shade in region 2. Region 3, plug in 1. 1 minus 2 is negative. Positive divided by negative is negative. Negative greater than or equal to 0, that's false. Don't shade in region 3. And region 4, plug in 2. 2 squared is 4. 4 minus 2 is 2. That's positive. Positive divided by positive is positive. Positive greater than or equal to 0, true. Okay, sorry, this region, and a single point. The way we write that is -infinity up to negative radical 2 parenthesis union the set consisting of 0. It's just a single dot. So this one has to be braces. It's not an interval. So don't put parentheses or brackets. Just a single number 0. Union parenthesis radical 2 comma infinity, like that. Okay. Let's see. See how much time we got here. 1.8 37. Okay, 1.837. I sort of went over that yesterday, but just quickly. You have a velocity function, 144 minus 32t. What's the velocity when it strikes the ground? Okay, so sketch the graph of v. Okay, the easiest thing to do there is make a little table. Plug in 0, and you get 144. Plug in 1, and you get 112. And actually, I know this is linear. It's a straight line. So that's enough. Okay, so a very crude graph is 0, 144, 1, 112. It falls. Something like that. Okay. And that's it. Let's just only do A. You don't have to worry about anything else there. Let's see, 1.2. What time is it? 45-ish. Okay, 1.2, 69, 59. Let's see. Okay, 1.2, 59. Okay, do that. 3. Oops, sorry. 2 over x minus 1 is greater than or equal to 3 over x plus 2. It's a 2. Sorry, look, almost looks like a 7. 2 over x minus 1 greater than or equal to 3 over x plus 2. Okay, subtract that over. 2 over x minus 1, leave a gap. Leave a gap greater than or equal to 0. Okay, so common denominator, this side needs that, this side needs that. So x plus 2 over x plus 2. And this one is x minus 1 over x minus 1. So x plus 2, x minus 1 is my common denominator. On top, it's 2x plus 4 minus, again, I'll play this trick. I'm going to change that to a plus and change this to a minus to remind. Okay, I highly recommend doing that so you don't forget to distribute when you see something like that. So minus 3x plus 3. Okay, so that's going to be 7 minus x on top. Greater than or equal to 0. Okay, so my boundaries are whatever makes the top or bottom 0. That's 0, negative, oh, I'm sorry, 7, negative 2, and positive 1, right? 7 makes the top 0, negative 2 makes the bottom 0, and 1 makes the bottom 0. Okay. So, sorry, I'm at the bottom of the paper. I'm going to come up. 7, negative 2, and 1. Come up, please. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Negative 7, negative 2, and a positive 1. Positive 7. 2, 3, 4, 5, 6, 7. Sorry, we're not using this. All right, let's see. 7 makes a true statement. Put a 7 here, 7 here, 7 here. At the top will be 0. 0 is greater than or equal to 0. That's true. Negative 2 will give me a 0 in the bottom. That's no good. 1 will give me a 0 in the bottom. That's no good. So both of these are open. Okay, I think I'm good now. Okay, region 1, 2, 3, 4. 1, 2, 3, 4. Okay, so what's something over here? How about negative 3? And region 2, 0. Region 3, 2. Region 4, 8. And these are all fractions, so fraction bar, fraction bar, fraction bar, fraction bar. And yeah, let me rewrite the expression. The expression was 7 minus x over x plus 2, x minus 1, greater than or equal to 0. Okay. So negative 3, 7 minus a negative 3 is positive. Negative 3 plus 2 is a negative. Negative 3 minus 1 is a negative. So two negatives makes a positive. Positive greater than or equal to 0, that's true. So region 1. Okay, 0, 7 minus 0. 0 plus 2, positive. 0 minus 1 is negative. So 1 negative means negative. Negative greater than or equal to 0, that's false. Do not shade in region 2. Region 3, 2. 7 minus 2, positive. 2 plus 2, positive. 2 minus 1, positive. Everything's positive, so positive. Positive greater than or equal to 0, that's true. Region 4, 8. 7 minus 8, negative. 8 plus 2, positive. 8 minus 1, positive. So there's one negative, that makes the whole thing negative. Is a negative greater than or equal to 0? No, false. So it looks like for my domain, I've got negative infinity up to negative 2, parenthesis, union, parenthesis, 1 comma 7, And 7 has a bracket because I'm including 7. So it looks like we got that. Okay. So that's that one. Let's see. Okay, I can tell I'm not going to be able to get through all the questions that are there, but try to do something. 1.357, I think I can do that quickly enough. 1.3, find the equation of the circle with a center 3, 7, tangent to the y-axis. Okay. In the interest of time, I'll just go quickly here. So here's a point 3, 7. So tangent to the y-axis means the graph just barely grazes it like so. It would go something like this. Okay, so it doesn't come across to here. It doesn't stop short. It just barely grazes it right here. So therefore, what is this radius? Well, it's a distance from here to here. Well, this x-coordinate is 3. That means the radius is 3. So this is my h comma k. Throw it into the formula x minus h squared plus y minus k squared is equal to the radius squared. So that's going to be x minus 3 squared plus y minus 7 squared equals 3 squared, which is 49. Okay, and let's see. Kind of have to pick my spots here. 1.337, okay. 1.337. What time is it? You got maybe 5 minutes or so. 1.337. Find the center and the radius of the circle. X squared minus 2x plus y squared equals 3. I'm intentionally leaving a space there. Okay, so I complete the square. So I do the half and square business. So half of negative 2 is negative 1. Negative 1 squared is 1. So you go plus 1, plus 1. Now, if they gave me like plus 6y, I have to do the same thing for y. But they don't give me any other y, so I can just leave it like that. So this now factors into x minus 1 squared plus y squared. Remember, y, you can pretend is y minus 0 squared equals 4. Okay, so the center, you change this sign, but it's still going to be 0. So the center is 1, 0, and the radius is the square root of this number, which is 2. So I'm going to go like that. Okay. Okay, quickly, 1.659. Coming close to running out of time here. .659. Okay. First, it says knots. Let's make our interpretation as miles per hour. I know they're not quite the same, but we'll try to make it the same. So 10 knots, let's make it miles per hour. Okay, so they give me this picture. So this is the port. And first ship is going 10 knots. Let's make it 10 miles per hour. Leaves at noon. And second ship, 15 knots, 15 miles per hour. Leaves at 3 p.m. Okay, find the distance between the ships as a function of time after 3 p.m. So t is time after 3 p.m. Okay, so I'm using distance equals rate times time. So time after 3 p.m., this distance is 15t. Okay, Okay, the rate is 15 miles per hour, and time after 3 is just t. This one, rate times time 10, but it had a 3-hour head start. So this one's not t, it's t plus 3. Like that. Which you're going to write as 10t plus 30. Okay, so it's not just Pythagorean theorem. So the distance squared is the square root of 15t squared. Sorry, the d. The d is the square root of 15t squared plus 10t plus 30 squared. And I'll just say et cetera for that. Leave the rest of that one alone. Okay. Yeah, it looks like pretty much we're out of time, folks. I won't have time to do another one. Okay, so sorry I couldn't get through all of them, but that's the best we can do. All right, so that's about it. I have office hours, but otherwise we'll see you for the test tomorrow. I told you all the ground rules already. So have your camera on and, you know, your actual background. I want to be able to see you. I will either email you or put on Canvas right at the top of the hour. So that's right at 9 o'clock. But I will, you know, show you, you know, like I did before, you know, show you the actual test in case you didn't catch that. And I'm not going to call the row, but I'll check the row. So you can't just not show up and turn in a test. I'll know, which means you didn't show me your camera, which means you could have cheated. So I'm going to count it as a 0 otherwise. Okay. Those of you that missed the roll call, just send me an email and you're good. And that will be it. All right. So that's it, folks. And remember, you have to turn in the homework also. 70% rule, turn in at least 70% of the homework. I'll take it early. If you want to turn it in at 7 a.m., you know, tomorrow, that's perfectly fine too. All right, that'll do it for today, folks. So bye, everybody have a good day. We'll see you tomorrow for the test. Okay, bye, everyone.